Okay, here is the video to explain slide 2 in lesson 3.1.3. And so in part A here, it's asking for what sequence of transformations will carry the one rectangle onto the other. So I'm going to look at from going from this left rectangle, how am I going to get it to land on top of the right rectangle here? Okay, and remember, our four transformations we know at this point are rotation, reflection, dilation, translation. Okay, and the first thing I'm going to do is a translation. Remember, translation is just sliding a shape up, down, left, right, diagonal. It's just sliding a shape. So I'm going to translate this shape over, and I wish I could grab it and move it, but we're going to have to visualize it here. I'm going to translate this shape over so that the corners line up, so that this corner up here on the left lines up on this corner here on the left. Okay, so then the shapes are pretty much on top of each other. It's just that this one is a little too small. And so that first one, again, I performed translation so that the left corners lined up. Then the second thing I would do, because I'm on that corner, which means this side is on that one, the top side is on here, I just need it to get bigger. So the second one is I'm going to perform a dilation to grow the shape to be the same size. Okay? Because then at that point, once I have it lined up, I just grow it to be the same size and they're laying perfectly on top of each other. So really just two transformations here, the translation and then the dilation. Okay? Now using the ratios to show that these rectangles are similar, okay, there's two different ways we can set this up and I'm going to show you both of them. Okay? The first one is to take the corresponding sides and divide them. So 7 corresponds with 2, 21 corresponds with 6, and so we could set them up that way. And we could do 7 divided by 2, and that would equal 3.5. And we could see that this would be the same for the other one as well. So if I did 21 divided by 6, keeping the corresponding sides dividing, big divided by little, I would also get 3.5. And so that right there shows that using these ratios, these shapes are similar because they had the same zoom factor. The other way to set this up could be to do instead of going corresponding sides, staying within the shape and dividing big side divided by little side. And so I could do 6 divided by 2. So this 6 here divided by the 2, and that equals 3. And then I could, not 34. I could also do the same thing, big side divided by little side on the big shape now, and that would give me 21 divided by 7, which also equals 3. And so either way you want to do it, either this top way, I'm going to delete that, either this top way or this bottom way, they are going to be ways that we can set up ratios to show that these shapes are truly similar because we get the same number when we do the division. All right, I hope this helps understand this kind of problem and the idea of equivalent ratios here a little bit more. And if you have any more questions throughout the lesson, just let me know.